Document embeddings are a foundational capability for building complex applications using large language models like GPT-4. In this video, you're going to learn how to install and use a simple proof of concept based on embeddings. You will also learn about foundational components of the solution from some experienced developers. Let's get into it. This is part 2 of episode 1 in our LLM strategy series. In part 1, I covered embeddings from the perspective of an analytics leader or product manager. So if you're interested in what embeddings are and what they can do, I suggest you watch the part 1 video. In this part 2 video, we're going to do a technical deep dive. I'm going to show you how to install and use the software that I demonstrated in part 1, and we're going to have a conversation with some of Prolego's engineers about the major components associated with building this particular solution. So let's jump into the installation. The installation instructions are all located on the GitHub repository at NeoSophia. There are 3 parts to the installation. The first is to install the base code for the NeoSophia application. The second is to configure it for a local environment. And the third is to run the particular code for that episode. So the instructions are all here on the screen. I don't need to go through all the details, so I'm going to show you everything in action. So in step 1, I'm going to install the NeoSophia code, which I just copied and pasted from the GitHub repo. Now that I have the code installed, I'm going to go ahead and configure it for my local environment. I'm going to use the default configuration paths, and I'm going to add my OpenAI API key in the background. Okay, now that the software is installed and configured, we can run the tests to make sure everything is set up correctly. Passed. So I'm first going to check out the episode 1 release. Next, I'm going to run the scripts that generate the embeddings from the MSRB rulebook. Now, this can take quite a bit of time, so I'm going to let it run in the background and come back when it's finished. Okay, now that the embeddings are built, we're ready to run the application. There's the command. And now I just need to copy and paste the URL into a browser. And here we go. So this is the same interface that I demonstrated in the part 1 video related to embeddings. So if you really want to see it in action, I suggest watching that video, but I'll show you a quick use of the document Q&A, and that is, am I allowed to donate to political campaigns? And it should do the document Q&A. And here is the answer. So everything seems to be working as expected. Now let's jump into a conversation with Prolego's engineers to talk a little bit about the major components in the code and how it's built. And hopefully this discussion will give you a better understanding of how you can start testing out the code and maybe changing some things to try it out in one of your own applications. We get into the details of the software behind this demo, and much of this discussion will be most relevant for developers and data scientists. But I don't want you to miss the key point of this episode, so I'm going to emphasize it here. We strongly advise you to take a capabilities-based approach to your AI strategy, and you'll see exactly why in this discussion. Once the team had built foundational capabilities such as PDF parsing, interfacing with LLM APIs, generating embeddings, calculating embedding distance, it was trivially simple to extend it to solving additional business problems. You'll see that it took the team about 20 minutes to add the document Q&A to the solution once they built semantic search. And while it will take longer to add new documents and solve more complex business problems, the capabilities-based approach will put you in the best position to cost-effectively scale your solutions and infrastructure. This is relevant to your AI strategy because taking an approach of building point solutions or, God forbid, buying a grab bag of third-party task-specific tools will set you on a path that just doesn't scale. Okay, well, welcome, Cam and Ben. So we're going to do a quick walkthrough of the code you guys built for episode 1 on the semantic search and document Q&A use case. So thank you guys for the hard work, and amazing how fast you guys were able to crank this out. So how many months did you guys work on this one?
0.001 months.
Yeah, so just from the audience perspective, this was a side of the desk thing that Ben and Cam cranked out on, and like I think we'll have to measure this in hours, not days. And so please withhold any harsh judgments of the coding practices. This was all in the spit. This was driven by the tyranny of the clock. So for the purpose of this discussion, guys, let's think about this for the type of developer who is familiar with Python. They can use Anaconda Git. They can use the basic tools, but they haven't done a lot of development with large language models or NLP. This is not someone with a strong data science background who just wants to get up to speed quickly and start figuring out, how do I use some of these tools inside my environment and in my application. So just sort of consider that context as you think through some of the answers. Why don't we start first by doing a walkthrough of some of the major parts of the code here. Okay, so we don't obviously need to go through every file on here, since some of this is experimental code that may not even be relevant for this first particular example. But let's talk through kind of step 1, which is the process of extracting the rules from the MSRB. So the MSRB is the rulemaking board. They've got a scintillating and incredibly interesting 400-page PDF read on the rules associated with municipal securities. So starting with a 400-page PDF, I guess I can't pump that directly into GPT-4. Is that the case?
That is the case.
Okay. So how do you go about parsing out a big complex document like that?
Yeah, so for something like a PDF that is not a scanned image, converted to a PDF, there's actually a lot of metadata within that PDF that we can use to extract the text and the data that we want. For example, for each paragraph or for each section header, you know where the bounding box is for that, you know the size of the pages, you know where the content is located on the page. So we came up with just a list of heuristics to extract the list of rules that we wanted based on the sort of templatized structure of how each rule is laid out. So most of the rules in this document are laid out in a similar format. So they have like some intro, very quick 1 or 2 sentence title of the rule. Then they have certain sections describing what the rule is about. And then ending with like the amendment history of the rule and other things like that. And so we were able to use that structure to pull out individual sections for individual rules and have that as our context.
Okay.
Yeah, I think if you scroll down a little bit, you'll kind of see the main logic
This
for
function
that.
right here.
I think a little bit further. Yeah. So here these big if else ladders kind of describe how we sort of expect, like the title of the section to come, and then the contents of the section, and there's like an interpretation section. So like you can see when we're kind of checking a state, we're doing these state machine transitions to help us parse out the different parts given this expected order.
Got it. And I given how fast you guys put this together, GPT-4 didn't automatically build this code for you, right? That's not the case.
No.
Yeah, so I guess after 6 years of us working in financial services, we run into a lot of situations where we have to extract information from PDFs. Okay, so a lot of like historical knowledge. But is this a generalized approach that you would use for most PDFs based on your experience? This kind of way of thinking through it?
Yeah, I think so.
The high level approach is generalizable. That if else slider that you were just showing is specific to this PDF.
Yeah.
Okay.
But yeah, given a similar PDF, again, that is not a scan of something, is an actual PDF, you can use a similar approach if you know the structure and the layout of the PDF to extract what you want.
All right. And so I'm assuming you can use this same type of workflow if you just want to find a specific section, like if you're trying to find like okay, fantastic. And
Yeah,
then, okay,
that
so
might
then,
actually be quite a bit simpler task, just finding specific text or whatever. It's kind of the fitting a pattern with maybe some different exceptions to sort of a structured result that's kind of challenging.
okay. And for somebody who's watching this, who maybe has a long PDF that's not an MSRB document, which there's probably not a lot of people in the world who are parsing the MSRB's rulebook. Like, as you start going through this, how does it work? Are you kind of like quickly testing and iterating through it to see what works? Like, is that how it just, or like what's kind of the first step as you start spinning it up?
I think first of all is just sort of the basic, using the PDF parsing library to extract those blocks or chunks of text that Cam was talking about. So kind of like he was describing, PDFs are sort of designed for printing, so they contain both text and formatting information. So you kind of pull out all those pieces, and then as you start looking and seeing what you have, you start building, you start trying to parse a certain expected structure, and then as you iterate on it, you realize that, oh, sometimes there's this exception or this exception, and then you sort of handle those different exceptions to the rules. And then in some cases, like you saw at the beginning, there's certain sections that we're ignoring just because there's different issues that we ran into parsing. So you might just say, okay, it's not worth it to sort of handle every one of these cases. We just want to focus on, getting 90% of it, right? So that's the kind of thing that you would iterate on.
Yeah, I guess having observed, I guess, some of the claims in the industry and the number of times that we've had to work on these kind of projects, there's the sense that, like, oh yeah, PDF parsing tools, there's a million of them out there, but when we get into any real problem, they never seem to work well, and we end up kind of doing it from scratch just because there's too many edge cases. All right, so I realize we're spending a lot of time on this, and I think for the people who are new to this, they might wonder why we're starting with PDF parsing instead of jumping right into the sexy cool stuff of using like GPT-4. But what's the main reason why you have to go through all this?
You need data.
There you go.
There's no application unless you have the data. And if we didn't do this whole parsing thing and we just read it flat, you'd run into the garbage in, garbage out scenario.
And you still need structured data, right? So
yeah,
if we're building an application that is supposed to, when we ask a question or search for a rule, if we find a match, we need to know where that match is, right? We don't want to just some random paragraph of text. We want the system to report, okay, this is in this particular rule, right? So at the very least, we need to be able to extract that kind of structure from the PDF.
All right. Is it fair to say this was the majority of the work of the project, was doing this? Okay. Yeah. Not surprising for anybody with real world experience. The data part is often the hardest part. So, all right, good guys. Right, let's get into more than some of the code that deals with actually interfacing with OpenAI and the models here. So I'm going to jump into, let's go to the LLM tools folder, and let's go through the OpenAI API. All right, wrappers for OpenAI API. So you're going to show me how we're going to interface with the API and all the complexities associated with creating document embeddings. All right.
Yeah, and this is actually a pretty simple module. It's just a basic wrapper that we wrote around the OpenAI API Python package that you can download. So they provide this API. Whenever I use things like this, I like to write a little wrapper that sort of makes the most common operations more clear and functional. The API is, as they provided, is like a pretty thin wrapper just around like the REST API. So it's not very Pythonic. So this is just trying to make their API a little bit nicer to work with. Right off the bat, there are just a couple of functions for setting the API key and loading it from a file, printing some nice error messages. And then I think the main thing that we're using here is the embeddings and chat completion functionality. Okay. But the embeddings, there's basically you can see the library call there on line 38. So they have a function called oai.embedding.create where you give it text and then you choose a model. I believe there's only really one model currently that you want to use, so I just made that a constant. And given that list of text, that kind of wraps that call. And then there's another function down below called extract embeddings that pulls out the actual data, because there's other results that come back and convert it into a PyTorch tensor, so it's ready to use in other contexts. And then I think embeddings tensor at the bottom kind of puts both of those together. So if you don't need any other information, if you just want to put in a list of strings and get out your embeddings tensor, that's what you would call it.
Okay, and I've looked at the OpenAI documentation. It seems like they just have simple examples like this, right? But so that some of this other code here, just things you created just to be able to work with it more efficiently.
Yeah, I mean the call, returns like a dictionary. I think you can see in like extract embeddings, like on line 59, there's like a subfield called data, and then within that is a subfield called embedding. There's other information in there that we don't really need. So this is just kind of pulling out the pieces that we need, not worrying about that other structure.
Right. It's all relatively straightforward development task, but for somebody who's seeing this for the first time, being able to see the working code and seeing how you get the results out of it, this can save you a lot of time. Excellent. Anything else we want to say about this particular file, or is that it?
I think that's pretty much it. It's just kind of a best practice for us to make simple wrappers around things so we're using the code the way we want to reason about it.
And in terms of the dimensions defaults or the default model here, was there any thought put into this, or was this like a number that came from OpenAI, or any experimentation there?
If I remember correctly, I believe that text embedding 8.02 is just like the current model. There isn't really much reason to use a different one, so I just wanted to make that a constant. And then the embedding dimension default, that's just what the dimension of the embeddings that comes back is. So I wanted to make that a constant. So you could make assertions against it for test purposes or just for reference, so you know what to expect from the result.
Excellent. All right, guys, let's jump into the first one. So now we've following the workflow here. We took in the PDF, we extracted all the chunks, then we created embeddings from them. And now we're going to deal with the interface, right? Which is under, there it is, this one, right? Yep. Interface.py. Okay, so this interface is based on an open source application called Gradio, correct? Which seems really useful for putting together very quick and dirty interfaces. Not going to win any UI awards, obviously, but for the purposes of demonstration, it works perfectly fine. Want to do a quick walkthrough of what we have here?
So let's see here. I think the first function here is
some initial setup.
Yeah, just loading in data. So we had saved the embeddings to a pickle file. We're loading them in, and then we're building this data structure that has a name and the original text that we generated the embedding from and the embedding itself. So that is kind of like that variable rules there on line 28. You can kind of think of that as like the database that we're going to be searching, just a list of rules.
Yeah. A list of embeddings for each rule.
Yep.
Okay. Should I jump into the main part of the program then?
Yeah.
Yeah. Like down to line 68 or so.
Sure.
Yeah. So there's sort of two main functions for this, for the interface. First is semantic search, and the second is question answering. So semantic search is user can do sort of like a control F, but in a smarter way. So whatever their search term is, we'll create an embedding from that, and then try and match that with the closest embedding for each rule. And we'll return like the top 5 rules that were closest to matching what their search embedding was. The question answering does the same thing. It takes their question, turns that into an embedding, and then uses a semantic search as a context generator. So you'll do semantic search on the whole thing. So you're not asking a question with the whole document as a context. Your context is what's returned from the semantic search based on your question. And so then, you input your question and you ask that to ChatGPT with the context of your search results from the semantic search, and then you'll get an answer from that. And it's cool. It shows like the most relevant rules to the question you asked. Same thing with the semantic search as well.
What I really like about this approach is that once you've done the upfront work of the the document parsing and data processing, and then you have the code to be able to get it into embeddings. After that, your ability to layer on additional calls of the GPT model to do more advanced reasoning or complexity, it's just I remember when you added the Q&A part of the document, it took you guys like about 20 minutes on top of the existing codes. It was shocking to me how fast it was. But once you have the semantic search, the document Q&A is just another call to the OpenAI API on top of that to reason across it. So all the building
Different
blocks are
prompts,
there.
different context.
Yeah, different prompts, different
That's it.
context, which is why this technology is so powerful. And if you get the basics down, you get the workflow, how you can start quickly spinning up more complex and more useful tools for your business customers. It's just that when you have the reasoning power of these GPT-4 models, it just gives you something that allows you to spin up really complex products pretty fast. It can make a pretty big impact. All right, guys. Well, I think that covers the main thing. Anything else in the code you want to cover through? Maybe for somebody who's new to it, something else you want to point out? Any gotchas?
We could just bring up the actual find closest embeddings function that's in simple search. That's what actually does the embedding search.
Okay, right,
Yeah.
great.
So and this is kind of nice because it's just sort of this very simplest way that
this right here. Okay,
yeah,
perfect.
Yeah, so what we're doing here is we have this list of records like or rules where we have, different fields like the name, the original text, and the embedding. And then given an embedding, we want to find the rules that match that embedding the closest, right? So it's actually really simple. We're just doing a dot product, which is just a mathematical operation between those two vectors across each. And then we're finding the embeddings with the largest dot products. So the dot product is happening in line 111. It's just a dot product from one against all the records. And then 114 to 115 is pulling out those rules that have the dot products that mean the most similar embeddings.
So I guess from a developer, maybe it doesn't have a lot of familiarity working with tensors in PyTorch. It looks like is this the only time you have to use the tensor? Is that one line? Is that it?
Basically, yeah. I mean, after that point, it's the dot product itself is just a scalar number. So then you can manipulate it with kind of ordinary Python functions or NumPy or whatever. So
okay, so then for someone who's just trying to get something up and running and doesn't want to go get a PhD, and they can copy this code and that can calculate distance, right?
Yeah, and this is not not a super efficient way to do it. You wouldn't want to scale this above a few thousand examples, but for a sort of proof of concept or even searching kind of a small local database, you could definitely implement something like this and build a nice application. So
excellent. And I guess it's also worth pointing out that where we built this demo, sort of a real-time interactive proof of concept, the particular use case we're talking about of comparing, of doing the tracing between, maybe a compliance department's policies and the rules regulatory. You could batch process that, in the background, and so that you'd have a search results ready for the customer real time. All right, well, guys, this is fantastic over. Let me just hit through a couple of the questions here. I guess the first one was like, what was any big challenges or surprises as you went through this code? Something that jumped out at you, maybe that you didn't expect?
Not a surprise, but the challenge of extracting the data was a challenge.
Okay, right. I thought you were going to tell me you didn't realize the MSRB's rules book was going to be so interesting and exciting, and that you couldn't put it down. That was
I read the whole thing that night.
All right, well, fantastic. Well, we touched this some of the discussion, but any other practical issues people would want to consider if they're looking at building a real application? I mean, obviously, I'm thinking about just a couple off the top of my head from the product side is just security, data privacy. Obviously, needing permission in this particular instance, your organization has to let you access OpenAI's API, and you have to be able to send the data outside your environment to OpenAI's API to generate the embeddings and to use the reasoning. So for some organizations, or some teams, that's going to be a challenge, and is why some of the emerging opportunities in open source that we're going to be covering in future videos will probably be interesting for those teams. And obviously, accessing the documents, we showed one simple example, but I mean, depending how messy and the variety, complexity, messiness, the documents location, that could be a big project on its own right there. Anything else you guys would have to jump up in terms of practical considerations that team should think of before starting to build something based on this code?
I would say if any of those things are a challenge, like accessing data data privacy, things like that. Just start simple and don't overthink it. Either use ChatGPT to generate some fake data for you, or just generate some fake data yourself. Doesn't have to be as complex as a whole 400-page rule book. It can be a document that's 1 page long with 10 rules, and that's it. The functionality of the back end is going to stay the same. It's just the data that's going to change. So just start quick and yeah.
Yep.
Yeah, I guess we've become I guess we're trained, because when we go to a client project and we've got to get something up and running quickly, we never have access to data, like ever.
Right.
So
Yeah.
like we're always like, all right, well, it does, the client doesn't care. We got to get something up and running in 3 weeks to like demonstrate the capability. It's like find something open source, generate something. Like you got to do something, and you can almost always find a way to get started, to get around that, to get something up and running, to demonstrate the capability for business customers and constituents.
Yeah.
Hey guys, thank you so much. Great overview. Appreciate all your hard work, and looking forward to the next one. Take care.
Thanks.
Well, that concludes our technical overview of embeddings, and I hope this information helps you get started building your own applications. If you have any questions, please check the show notes in today's video, or you can jump on our Discord channel and ask us any questions. Of course, building a demonstration proof of concept application like this is much simpler than solving real business problems in the enterprise. And so if you want to talk to us about your particular problems or any help you might need in solutions, our contact information is on the screen. Just email my business partner at russ@prolego.com. Have a great day.